Hi to all. In this video, we are going to see about classification of insulating material based on thermal consideration. It comes under electrical machine design 18EE55 model 1. Okay, based on thermal consideration. Okay, why it is called based on thermal consideration means the temperature, maximum temperature that can be withstand. Okay, that's some of the materials. Okay, let's see the previous and present. Why is the code for that is a 90-degree. It can withstand typical materials for this cotton, silk, paper, wood, cellulose, fiber, etc. without immigrations or oil immersed. This can withstand up to 90-degree. Okay, when you come for next one, A. The previous letter also A. Now again the new also A. That's it can withstand up to 105 degrees Celsius. The material of class Y, the same materials, cotton, silk, paper, wood, cellulose, fiber, etc. Impregnated with natural resins. Then the temperature it can withstand up to 105 degrees Celsius. Okay, so third one E is nothing but right, that materials we can withstand up to 120 degrees Celsius. Synthetic resins enables of vinyl acetate or nylon tapes, cotton and paper laminations with formulated bonding, etc. When you come for B, okay, it can up to 130 degrees Celsius. Then mica, glass fiber, asbestos, etc. with suitable bonding substance. It can withstand up to 130 degree. F. When you come for F, it's a 150 degree. Okay, the material of class B with more thermal consideration, then it becomes a 150 degree. Okay, and H 180 degree glass fiber and asbestos materials built. Okay, C the above 180 degree the mica, ceramic, glass, quartz and asbestos with binders or resins of super thermal. Okay, so these are the materials based on that temperatures it can be classified. Insulating material can be classified as solid, liquid and gaseous and vacuum. The term insulating materials is sometimes used as a broader sense of designates also insulating liquids, gas and vacuum. Solid used with field, armature and transformer windings. Okay, transformers we are using this one, as well as liquid also we are using in transformers. The examples fibrous or inorganics, animals or plant organics, natural or synthetic, paper, wood, cardboards, cotton, jute, silk, etc. These are things which is used in transformers. Plastic or resin is a natural resins, amber, shellac, etc. Synthetic resins, formaldehyd, melamine, polyesters, epoxy cements, resins. These are the also materials which will be comes under insulating. This solid insulating materials. The main difference between solid, liquid and gaseous materials are, if you go for solid material, if it dielectric property broken or if it breaches the dielectric property, then it will not regain its dielectric property. When the case of solid, liquid and gaseous, if it breaches the dielectric property, after few seconds it regain its original property, that is dielectric property. That's the main difference between solid and liquid and gaseous dielectric materials. Okay, plastic or resins, minerals, these all the things are comes under solid dielectric materials. Okay, plastic, resin, natural resins, slacks, ambers, all things comes under that one. Rubber, natural rubber, synthetic rubber, betadine, silicone rubbers, hypolan, etc. These are the things also comes under solid dielectric materials. Minerals, mica. In solid dielectric materials, rubber, mineral, ceramic, glass, soda lime glass, that porcelain. Okay, mica, marble, everything comes under solid dielectric materials. When you come for new non-resinous mineral waxes, bitumen, chlorinated naphthalines, enamels, etc. Okay, when you come for liquid used in transformers, circuit breakers, reactors, rheostats, cables, capacitors, etc. for implementations. The examples. Okay, transformer oil, that mineral oil used as a transformer oil, that as a transformer oil, which will be used for two purposes. One is used as a insulation between the coils, okay, and another is it's using as a cooling purpose, okay. And synthetic oil or Oscarnel panel, etc. are used. Varnish, which is used in the windings when we wind in motors as well as generators as well as transformers. The windings, the winding copper windings should not short circuited when the temperature or increases. So when we go for a varnish, that transformer coils will be dipped into the varnish, so it will make a protection between that nearby coils. Okay, gaseous. Okay, gaseous, I told no, there are three types of insulating materials. One is solid, liquid and gaseous. In liquid also, once it reaches that dielectric breakdown, after some times it regain its dielectric strength. Okay, but in the case of solid, when it is a solid, it breaks dielectric strength. It will not regain its dielectric strength again. Okay, and gaseous air is used in switches, air conditioners, transmission and distribution lines, etc. Okay, nitrogen used in capacitors, HV gas pressure cables, etc. Okay, they are we're using nitrogen. Hydrogen we are using through not used as a dielectric, generally used as a coolant. Hydrogen. Okay, SF6 sulfur hexafluoride we are using in circuit breakers. SF6 circuit breakers, there we are using SF sulfur hexafluoride gases as a insulating material. Okay, inert gases, neon, argon, mercury and sodium vapors generally used for neon sign lamps as the insulating materials. Okay, halogens like fluorine used under high pressure in cables. Okay, no insulating materials in practice satisfies all the desirable properties. Okay, some of the drawbacks will have for the all the insulating properties, insulating materials. Okay, where we need which type of material, that thing we should decide based on that type of machines. Okay, the insulation system is also called insulation class. For wires used in generators, motors, transformers and other wire-wound electrical components is divided into different classes according to the temperatures. That one, this one. Okay, the wires which is used based on the temperatures, it can be classified into Y, A, E, B, F, H, C. These things are mentioned in that motors, generators, transformers itself. A class insulation means it can withstand up to 105 degrees Celsius, like H or F class insulation are used in that machine, class F. Then it can withstand up to 150 degree Celsius. Like that, it will be okay. In gaseous, the examples are SF6, like that. SF6 is used for the circuit breakers, sulfur hexafluorides. Okay, so insulation systems are also okay. Electrical insulation IS number 1271 1985 first revision and other international standards installations is classified by letter grades A, E, B, F, H. Previous Y is that up to 90 degree, A 115 degree, E, B, F, H and C. C is nothing but 180 degree and above. Okay, this the maximum operating temperature in the temperature insulation can reach during operation, and in the sum of the standards ambient temperature, that is 40 degree centigrade permissible temperature rise and allowable tolerance or hotspot in windings. For example, the maximum temperature of class B insulation is ambient temperature 40 degree plus allowable temperature of rise of 80 degree, that is 130 degree. Okay, insulations in the weakest elements against heat and the critical factors in the deciding the life of the electrical equipments. The maximum operating temperature prescribed for different classes of installations for a healthy lifetime of 20,000 hours. The highlighted temperature permitted the machines 200 degrees Celsius. Okay, exiting the max. Thank you.